In this video, I'm going to teach you how to find a z-score and then use the z-score table. So in this question, it says the amount of soda in a 12-ounce can of soda has a normal distribution with a mean of 12.25 and a standard deviation of 0.15. First, we're just going to find the z-score for a can that is actually 12 ounces. So basically what this problem is saying is that even though it says 12 ounces on the can, it may not be exactly 12 ounces. It's saying that the average can is going to be 12.25 ounces and it has a standard deviation of 0.15 ounces. If we plug this into the z-score formula, X is the value that you're interested in. So in this case, that's 12 ounces. We're going to subtract the mean and then divide by the standard deviation. Now, anytime you are calculating z-score, no matter what the number is, you must round it to 2 places. So in this case, our z-score rounds to negative 1.67. You must round correctly in order to get the next part of this right. It's always rounded to 2 places, and you need to make sure that you round correctly. So a negative z-score means that our value is below the mean. In this case, we're talking about 12 ounces. This z-score indicates that 12 ounces is 1.67 standard deviations below the mean. We're going to use that to answer the next part, which is what percent of soda cans contain less than 12 ounces. I always like to draw a little curve just so I can visualize what's happening. Your mean is in the middle at 12.25, and we just said that 12 ounces is below the mean. So I'll just say it's around right here. We want to know the percentage of cans that are less than 12 ounces. Well, our empirical rule only deals with exactly 1, 2, and 3 standard deviations away from the mean. Our z-score is telling us that we're not exactly 1 or 2 standard deviations from the mean. We're 1.67 standard deviations from the mean. So what we have to use now is the z-table. So to read the z-table, you need to know your z-score, and you find it either on the left-hand side with the negative z-scores or on the right-hand side with the positive z-scores. If you look at the pictures above, notice that in both curves, there is shading to the left in each curve. That's because your z-table only tells you the percentage below the z-score that you're finding. So the z-score that we had was negative 1.67. That means I am focused on this side of the z-table because it's all of my my negative z-scores. This column, let me draw on it really quick. This column is the 10th place of your z-score. And the row across the top is the 100th place of your z-score. This applies to both the positive and the negative side of your z-table. So in our specific problem, we had a z-score of negative 1.67. This is the left side of the Z-table. Along that column on the left, you're going to find negative 1.67. And then across the top, you're going to find your along the column, you're finding negative 1.6. That's the tenths place. Along the top, that's where you're finding your hundredths place, which is 0.07. So negative 1.6 represents the tenths place of my z-score. 0.07 represents the hundredths place of my z-score. And now you just find where those intersect in your z-table. That would be 0.0475. So like I tried to explain when I had the whole z-table in front of me, was the shading on the top is indicating that this number, 0.0475, is the area to the left of that z-score. In other words, this shading right here is equal to 0.0475. If we convert that to a percent, we find that 4.75% of the cans contain less than 12 ounces. So that's how you use the Z-table if you want a value less than or to the left of a certain value.